Good evening, my dear students. So, in this class, I am going to explain about how to design the steel beam. So, in the RCC, you know that how to design a steel beam. So, beam is a structural member subjected to the flexural load or bending load. So, column is different, beam is different. What is the function of the beam is whatever the load coming from the slab to take care of the beam and transfer to the column and transfer to the footing itself. That's why a beam is a mediator in between the slab as well as the column as well as the footing also. That's why we are going to design the steel beams very carefully. So as far as the syllabus is to be concerned, we are having the design of the laterally unsupported beam, design of the laterally supported beam, and design of the conjugated beams or it is the rolled steel beams also. So first of all, I have to discuss about what is the introduction about the steel beam. So beams are primarily structural member suppose loads applied perpendicular to the longitudinal axis. So whatever the longitudinal axis is there, the load is acting perpendicular to the longitudinal axis. These loads will be take care of the slab itself. They form an essential form of the steel structure such as either the buildings or the bridges or the industrial sites and the platform also. So water tanks, steel water tanks. So bridges, steel bridges and trusses also, steel trusses. The buildings also have to be constructed with the help of the sets also. So with the help of the I sections or the channel sections, we are going to build the structures also. The main function of the steel beam is to be resist the bending moment as well as the shear force. So with the application of the load itself, we are getting the shear force as well as the bending moment caused by applied load, thereby transferring the load safely to the supporting members such as either the columns or the walls itself. So I told already the beams are primarily subjected to different types: laterally supported beams, laterally unsupported beams, and girders. So laterally supported beam is a structural member whose compression flange is prevented from the lateral movement and twisting along its length. Laterally unsupported beam means so the beam is laterally unsupported. So that's why because of this restraint, the beam can develop its full bending strength without lateral torsional buckling itself. So how lateral support is to be provided? Lateral support is to be commonly provided by the slab attached to the compression flange. Example, RCC slab in the composite floors. So in the composite floors, we are having the RCC slab or cross beams or the floor beams. So these are the main beams, cross beams or the shorter beams. So continuous buckling, sheeting or bracing system, the purlins and seatings as in the case of the roof trusses also. So what are the design implications are to be there as per the design of the unsupported beams? So for laterally supported beams, what are the design checks? So whatever the section we are going to select, whether the I section or the channel section or the beam section or a T section, whatever the section, either in-standard equal angle section or in-standard unequal angle section, whatever the section we have to choose, this include bending strength, moment capacity you have to check. And the second one is to be shear strength and serviceability means deflection limits and web buckling as well as the crippling also. So web buckling means inside the web it will buckle, that is called as the web buckling. Outside the web, if the buckling will be occur, that is called as the web crippling. No reduction is to be required for the lateral torsional buckling since the beam is to be restrained. So how to design the laterally supported beam in this class I am going to discuss. So the design of the lateral supported beam is to be designed with the help of the IS code IS 800-2007 and the steel table. So first of all, you have to choose a section. So from that section, you have to write whatever the thickness of the flange, whatever the thickness of the web, what is the depth of the section, what is the radius of the gyration, what is the cross-sectional area, we are going to write for particular section. So my sincere advice is to be, my dear student, as far as the beams you have to consider IS medium flange beams. Why? Because IS lower beams are there, medium flange beams are there, wide flange beams are there, high flange beams are there. Don't go for IS section, don't go for lower section. You have to take middle ISMB, Indian Standard Medium wide flange beams you can take. If it is reduced, you can go for ISLB. If you increase, you go for ISHB. Number of trials will be reduces. Suppose if you take instead of ISMB, if you take ISHB, suppose if it is more, you have to choose for either ISWB or ISMB or ISLB. Number of trials will be more, your time will be consuming. So that's why my sincere request is that you have to take the middle one. The middle one you can take increase or decrease based on that you can choose either the ISLB or the ISMB section. So given data is to be span of the beam is to be given in between the supports and the type of the loading. Type of the loading means whether it is uniformly distributed load or the point load or the combination of the UDL and point load. Factored loads, small w and capital W. So, as in the case of the central point load, we have to take capital W. As in the case of the simply supported beam, we have to take the small w. So, material grade, you can take FE 250 or FE 415 or FE 500, FE 550, FE 600 is also there. Support conditions, whether the simply supported or continuous supports. So, calculate the factored bending moment. Suppose if the beam is subjected to UDL, you know that shear force is to be WL by 2. So bending moment is to be W L square by 8. Suppose if the beam is a central point load W by 2 is the shear force, bending moment is to be W by 2 into L by 2 WL by 4. So based on the beams, based on the conditions of the loading also, whether it is the point load or the uniformly distributed load or the combination of the point load or uniformly distributed load, you have to calculate the shear force as well as the bending moment. You are already calculated in the strength of materials. The beams are different, beams are there, simply supported beams, continuous beams, fixed beams, conjugated beams and overhanging beams or doubly overhanging or singly overhanging also. So that is the minimum basic knowledge of the beams itself. So suppose central point load WL by 4. Okay. So for that purpose, you have to calculate the shear force and bending moment. After that, you have to see that from the bending, from the IS 800 2007, you have to calculate the bending strength of the beam. So whether the bending strength of the beam is to be more than your bending moment value, it will be okay. Suppose sometimes the bending strength of the beam is to be less than our the bending moment calculated for type of the load is to be acting on a particular case. Then you have to modify the section. Suppose if it is more, you have to reduce. If it is less, you have to increase. So that's why you better to take ISMB, medium beams. So if it is less, you can go for ISLB. If it is more, you go for ISHB. So that's why you have to take the design like this. So after that, you have to check the design bending strength or design shear force also, the deflection also. So one check is to be necessary. Suppose if you are going to check the bending moment, whatever the design bending strength calculated from the formula is to be given IS 800 2007, that should be more than your bending moment calculated for the given loading conditions. So suppose if you are checking for the shear force, the bending shear force formula is to be given in the IS 800 2007. This should be more than your calculated shear force. Deflection also you have to check. So with this, you are going to design the laterally unsupported beams. So these are the reference slide links. In the next class, I am going to discuss about the design of the supported beams as well as the rolled steel beams also. Rolled steel beam is nothing but a multiple beam. So I section is to be connected to another I section, channel section is to be connected to another section. So thank you very much for listening my class. If you have any doubt, you contact me. Next class, we are going to discuss about the design of a laterally supported beam as well as the rolled steel beams also.